Hi, welcome to the official channel Design and Simulate. This is the walkthrough of the ANSYS problem, which is the 3D cantilever beam under the influence of its own weight. It's a static structural analysis, and we'll go step by step on how to perform this analysis. First, you need to open the main program, which you can find when you click the window. You'll see this ANSYS Mechanical APDL product launcher. After seeing this, you just need to click this product launcher, and then you will see this window will appear. This window has some settings, two set of menus in the above, and here you will define your working directory and your job name. Here you need to select ANSYS, and you can select the licenses that are available for you. And then you need to select the working directory in which you need to work. You just browse and select that specific working directory, and then you need to give a job name to this problem. Once you define all the previous things, here you will specify that which type of analysis you want to perform. So the first tab in ANSYS menu bar is the preferences. So in the preferences, you will select this structural, since we are performing this structural analysis. Next comes the preprocessor type, the second option. And the first thing in the preprocessor are the element types. If you have taken the course of finite elements, so it's very clear that what are the element types and what to do and why do they select and what are different types. We are not going to explain the specifics for this element type here in this video. It's only a tutorial to perform this cantilever setup. And then you just need to add this element type, and here we are using this solid, and we are selecting this 20 node 186 element. So you just define this, you select the solid 20 node 186 and you press OK, and then you close this element types. Keeping in the preprocessor menu bar, now you need to define the material properties. So to define the material properties, we just go to these material models. Since we are performing an elastic analysis, we are assuming that the cantilever beam is elastic in nature. So we only need to define the modulus of elasticity of steel and the Poisson's ratio as given here. We don't need to specify any other properties, but if you are considering your beam to be nonlinear or you are performing some other analysis, then there are other options available. But for this analysis, you only need to plug in the elastic modulus and the Poisson's ratio. Next, you need to give the density, since this analysis assumes that the beam will deform or deflect based on its own weight. So therefore, we need to specify the density so that the solver, it can calculate the weight of the beam, and then it can deform it under its influence of its own weight. And you need to be very careful with ANSYS. As you might have known, that ANSYS software, ANSYS APDL, it does not have any predefined unit system. So all the unit systems comes from the fact which properties you give. So like previously, we have given the modulus of elasticity in newtons per millimeter square, and also now we are specifying density in kilogram per millimeter cube. So you need to use this value for the density of the cantilever beam. Next is just go to now we need to model the beam. So we are not importing any model. We are generating the beam model inside the ANSYS. So we'll select this preprocessor. We are still in the preprocessor. We have given element types. We have given the material properties. And now we are modeling the beam, and to model this we are creating a volume, and we are creating this volume by selecting these two corners and a Z. Z is the length, the beam length, and here when you click on this by two corners and Z, you need to specify the width, the height, and the depth of the beam. And the 0, 0, these are basically the coordinates. So it will keep the start from here, the coordinate in the coordinate system from 0, 0, and it will go 10 in the X, 10 in the Y, and 100 mm in the Z direction. And here when you press OK, so you can see that the beam has been generated. That's the corner. And here it's 10, and here it's 10, and in the Z direction it's 100. After that, now we need to we go to the next module, which is the meshing module. So we have defined the element type, material properties, we have modeled this beam, and now we need to discretize so that we can generate the elements, and after that we can perform the analysis. So initially when you go to meshing, you select the mesh tool, and when you select the mesh tool you will see this bar, and now here are different options of how you can mesh. You can directly generate the mesh by selecting the solid and volume and just click the mesh, and it will can generate a random mesh. But here we are teaching you how can you control the specifics of your mesh so that the mesh you generate is of good quality. So we select these. Initially we set the lines. We can also set the areas, but here we are further going deep down into the geometry, and we are setting the lines. So you need to click set lines, and initially we need to select these 4 long lines. So we select these 4 lines, and then we give them the number of divisions. That's our own choice. If you need to refine your geometry, so you can just change this value to 50, 60, 70, 80, or 100. Here we are keeping it 40. So enter this value, just press OK, and you can see here now that these lines have been discretized into 40 small elements or divisions. Similarly, now you need to select again set lines, and we need to select these 2 square lines at both the ends, and here we are just giving them a number 6 to these lines. The element division is 6 for them, and just press OK. And then we have defined the lowest entity in the geometry, so we don't need to worry about the area, meshing the areas. We don't need to worry about meshing the volume. We just directly go and select the volume, click hex, since it is a very calculated divisions which we have given, and by calculated I mean that the adjacent lines are equal. So if this line has 6 divisions, then the adjacent line has also 6, and the adjacent lines has also 6. So 6, 40, 6, and then again 40. So it will create a hexahedral mesh, which the ANSYS it calls the hex mesh, and it's mapped. Mapped means that both the adjacent sides have equal number of divisions. So you just select the volume here and then click OK, Here we have given that how the steps you need to follow. First, in the first step, you need to select this hex. You need to click the mesh. You need to select the volume, and then you click OK. And after that, your volume mesh will be generated. You can see that. And now we will go to this preprocessor. Okay, we have completed all the previous steps, and you can see in ANSYS it's very convenient and easy that all the modules which we need to follow to perform an analysis, they are given in a sequence. So you just follow the sequence, select the required option for that analysis, and you can get them. So initially you just we have defined the element type, we have defined the material properties, then we modeled, and then we meshed the model, and now we need to define the loads on the beam. The first is the boundary conditions. So we need to restrain some degrees of freedom of this beam so that the beam is fixed on one side, and we don't apply any load, so it will be formed under the influence of its own weight. So initially we need to select this area here, and then you need to go to the loads, you need to go apply structural displacement on areas. So when you click this, when you click this, when you follow these steps, so it will ask you to select the area. You need to select this one area where the x, y, and z axes are 0, and then you just need to click OK. After that, it will ask you, okay, what kind of degrees of freedom you want to restrain. I mean, either you want to restrain it only in x, y, and z direction, or there is a third option in which it will directly, you don't need to select them one by one. You just select this option, all degrees of freedom. So you can just select this all DOF option and then click OK. Then you need to select. Now we need to define the gravity, since this beam will be subject to its own, will deflect under its own weight. So we need to define these all the elements, the density which we gave. We need to tell ANSYS, okay, that this is how these are on these elements we will apply the effect of gravity. So for that we need to create a component. So you just go to this select, you click component or assembly, and you click create component. Then you just need to specify any name that, like I have written here, it's beam. You can give it it's beam 1, beam 2, or cantilever beam, or anything. You just name it, and then you just select the elements that you want to create a component that is made up of elements. And after that, you can see that your name will appear here. And now you have created, in the previous step you have created the components. That step is finished. Now you just go to apply structural inertia gravity on components. So we need to create a component first that we have created, and once we have created the component, we can simply go and we can apply the gravity on those components. So now you can understand why we need to create that component, and you can see here in all caps, whatever you have written there, it will appear in all caps in here. So that's your component, and here you can also see that there's a drop box. So it means that in your simulation there could be multiple components, but we are not going to discuss the multiple components here. That's just something to teach you that how you can create a component in ANSYS. And finally, in the y direction, we will specify this y component gravity. And as I told you, that you need to be very consistent with your unit system, since we are dealing with in kilogram, Newton, and millimeters and seconds. So That's why we need to define the acceleration due to gravity of 9810, not 9.81. And once all these have been defined, you have completed all the previous steps. You just go to the solution, you go to solve, and you just click the current load steps, current LS. So you will click OK, it will begin to solution, and you will see this message, your solution is done. Once you see this message, means that your solution is now complete for post-processing. Now, initially you just click the plot results, and you contour plot, and you go to this nodal solution, and you can simply see your deformations in the beam. It's a typical cantilever deflection. You can see, and we have not applied any external loads. It is deflecting on its own weight, and we get around a deflection of 0.579847 millimeters. And here you can also see, if you go to this result viewer, you click von Mises stress, and you want to see the stresses in the beam, and you need to click this von Mises option. You can also see the other components if you are interested. Here we are only interested in to see the von Mises stress, which we can compare it with the yield strength of the material. And you just click the contours and plot the results. And here now these are typical stresses in the beam, and you can see that under the influence of its own weight, if we have this rod of 100 mm length and 10 mm width and height, and it will deflect around half of a meter. And you can see you can assume that the stresses which comes around are 263 megapascal. The stress units of the stress, it comes directly from the units you have given to the modulus of elasticity. It's in Newton millimeter. So you need to be, I'm repeating again and again, you need in ANSYS, you need to be consistent with your units. If your length is in meters, keep your unit in meters. If your length is in millimeters, keep your units in millimeters. If you have weight in pounds, keep your everything in pounds and foot. So first decide which unit system you want to follow, and then you can easily give this.